Hello everyone, welcome to Zero to App, where we'll be live coding an app. This was originally called Building an App in an Hour, but I've only got half an hour, so it's going to be a bit of a challenge. My name is Kat, and I'm a software engineer on the Firebase team. Lawrence just talked us through a bunch of the features of Firebase to build your mobile apps, to help develop faster and grow your applications faster. Mobile apps these days are more powerful than ever, and it's because of the device that they are built on, mobile phones. These devices 50 years ago were a piece of fiction. Now they're small enough to fit in our pockets, but powerful enough to have solved one of communication's greatest challenges, allowing us to connect to one another no matter where we are in the world. So what is communication's next great challenge that we'll need to solve? Well, what about language? I'm here today speaking to you in English because I haven't mastered Korean yet. But if you look to science fiction, there's a bunch of very cool solutions. My favorite comes from a book that's popular in America called The Hitchhiker's Guide to the Galaxy, where Douglas Adams gives us the babblefish, a little fish that lives in your ear, listens to the world around you, and speaks in a language that you understand. Unfortunately, that's not real, and in 30 minutes, I cannot train a fish. But you know what I think is possible? I think we can build an app. This app should allow me to select the language I understand, English, and I should be able to speak into it in English, and should allow you to select that language you understand, Korean, and allow you to hear what I have said in English in your own native language. If we were to build this app traditionally, we might follow this sort of architecture, where I've built my app that has in my UI, but it talks over a RESTful interface, and most of the interesting computation happens on an application server. So the translation, the storing of files, and this may call out to cloud APIs, perhaps to make use of cloud database solutions. In fact, my application server may be a cloud VM, may be in the cloud itself. But that takes a long time to build, and then we would have to secure it. But what we're really interested in is building our app. Good thing we're here today at Zero to App to talk about how to build an app with Firebase. With Firebase, you take your phone, you take your app, you drop in the Firebase SDK, and that directly connects your device to powerful managed back-end services, such as database and storage solutions. We don't need the middle-tier architecture. We can connect our devices straight to the cloud. Today, I'll be talking about 3 developed primitives. First, cloud storage, a solution to help you store your files that can scale to exabytes of data. That means you can store your petabyte files, and it'll just scale as you grow. Authentication, a serverless system to help us manage our users and sessions. And the real-time database, which allows us to synchronize JSON data in milliseconds. So how do we use this in our app? Let's break it down a little further. First, there's cloud storage, which allows us to store the audio files that we record. Firebase gives us client SDKs that allow us to upload files in 5 different platforms, from Android, iOS, JavaScript, Unity, and C++. It helps us upload our files and download them from Google's world-scale network. Even if we have flaky Wi-Fi, if we're in the subway or somewhere a little remote, we'll handle those broken connections so that your files are robustly uploaded. And you can secure your files by selecting who has access to download files and the size, and even specify the size of files that people upload. This requires some notion of users, for which we can integrate with Firebase Authentication. Like Lawrence mentioned, it allows you to log in with many different social providers out of the box, such as Google, Facebook, Twitter, GitHub, but also allows you to sign up with email and password and phone number authentication. And if you have your own custom authentication already, your own single sign-on provider or SAML or Open Directory, you can integrate with custom authentication. So no matter where your users are coming from, whether it's Facebook or GitHub, you have one single user ID that you can use across your entire app. Again, this happens entirely in the client side. You don't have to run a server in order to get this power. So we'll be able to say that only logged in users are able to upload files and use our app. Now that we have users, we want to be able to tell them when there is new content. For that, we'll use the real-time database. The real-time database is a NoSQL JSON database. That means we can store our data like this. We have an uploads node, and for each one of our uploads, we'll want to include the language that it was spoken in, as well as a reference to where the audio file lives in cloud storage. Now, with other databases, we would follow a request-response paradigm, where every time I want to find out if there's new content, I would have to request the database for new content. The real-time database is different. It instead pushes data to the clients. So each client, each device just has to specify where in the database it's interested in listening to. In our case, it'll be interested in listening for the translations. And then whenever a new translation happens, that data will automatically get pushed down to the clients. All right, that was a lot of talking about what we're going to build. Let's actually get down to building it. All right, here you can see that I have an iOS app. Today I'll be using iOS, but everything I do here has a parallel structure in Android. And I'm sure that some of you are iOS developers or Android developers, and if you're not, I'm sure you work with some or want to be able to have your app perform on both platforms. So Firebase also helps with cross-platform applications. Here I have a selection so that I can select the language I'm going to record in. I'll be able to record and log in, but none of the functionality is actually hooked up yet. So let's go ahead and do that. The first thing we're going to want to do is actually connect to Firebase. These three lines allow our app to connect directly to Firebase. And prior to this, I've included a plist file, which allows me to specify which Firebase project we're speaking to. So these three lines allow us to connect directly to the back ends. The next thing we're going to want to do is actually upload our file. This here selects our local file, and this creates a reference in the cloud storage so that we can specify where we want to upload it. Then I also go ahead and specify some metadata, including the encoding for our file type, so that we'll be able to decode it and transcribe it into text. Once I have my file and the data that I want to actually upload, I just write put file. This sends my file along with my metadata to the cloud. Easy as that. And here I handle an error. I just show the error if it happens. Otherwise, I post that it uploaded. And when it uploads, I also want to write to the real-time database so that my other users can find out that there is a new translation. Here, I write out what I'm going to upload to the database. Again, it has the encoding as well as the language that I've spoken in. And to actually write to the database, I call setValue. This writes the data that I have specified here to the database. All right, so if we go ahead and run our application now, I'll leave it on English since that's what I'm speaking in, and I can record. Hello world. Oh, we got an error. That's because we haven't signed in yet. Only people who have signed in can actually use our application. So let's go ahead and integrate in Firebase Authentication. The first thing we're going to have to do is figure out whether or not our users are actually signed in or not. When they're not, we'll want to show them UI, which allows them to log in. This can take a lot of time to develop and is something that's you just have to do, but Firebase provides an open source SDK called Firebase Ui, which provides you with default authentication flows to use with Firebase Authentication. So the first thing we're going to have to do is check whether or not the user is logged in. If they're not logged in, we'll go ahead and use the Firebase Ui Library. Here we specify that we want to allow users to log in with the Google provider, but we can also specify Twitter and GitHub and Facebook as well. And we'll go ahead and pop them into that particular sign-in view. Then if they are logged in, we'll want to provide them with a way to log out, but also listen for any new translations that are happening. This is when we'll listen for and read from the database, or rather wait for the database to send us new information. So we'll go ahead and listen for the new translation. First, we'll need a reference to the location we're interested in the database. In this case, we're interested in the translations. Once we have a reference to the translations, we can go ahead and query for updates. Here, I'm only interested in the last translation that has happened. And whenever that happens, a new translation has been added, called child added. We'll get this method called back. Once we know that there's a new translation, we'll want to listen and specify the specific language that we're interested in listening to, dependent on what language the user has selected. So we'll use listen for language and repeat this, where we'll get a reference to the particular language that the user has selected. And when there's a new value for that, we'll be able to grab that information, pull out the translation text, and then update our UI and use existing text-to-speech APIs to go ahead and play the text. So if we run our application now, we get a login screen because we're not yet logged in. I'll go ahead and select sign in with Google, use my demo account here. Now when I record hello world, pops up that it says it uploaded. Now to see that it actually made it to the cloud, let's check out our storage uploads directory. This is the Firebase console, the web UI to administrate our Firebase project. And you can see here that I have a file uploaded. And if I check the real-time database, I'll also see that I have this information as well, the encoding and the language that I spoke in, English. All right, so we have most of an app except for the part where we listen for translations. So let's go ahead and see if that part works. I'm going to run a test to make sure that our apps are actually listening for translations. Here I'm just going to manually translate from English to English what I said here.
Hello world.
And if I jump back to my app over here, you see that Hello World has actually popped up, and you just heard it speak using the text-to-speech API that I said Hello World. All right, so let's go back to the slides. We've built most of an app, right? There's just two problems. One, I manually translated from English to English. That's not very interesting. The second problem is I still don't know Korean, and if I want to support Korean in this application, I'm not going to be able to do all the translations myself. But I hear machine learning is pretty cool. Maybe we can get the computer to do this for us. And cloud provides some interesting machine learning APIs. Good thing, every Firebase project is also a cloud project. That means your Firebase app can easily integrate and use all of the power of cloud platform. So let's go ahead and add some machine learning. Today, we're going to add the Cloud Speech API to transcribe our audio file that we have just uploaded into text. And then we'll take our translation API and take that English that I spoke and turn it into Korean and German and Dutch and every other language that we want to support. All right, but there's a couple of challenges when it comes to building a serverless app. First of all, is everything I've built in my iOS app, I will also need to build in my Android app. That means I have to keep multiple code bases for every functionality. Second, there's a problem of computation versus battery. For example, today I'm using a machine learning API, but if I were to perform the algorithms on my device itself, I would probably run out of battery before the end of the day, and I would be stranded in Korea at maybe 7 p.m. trying to get dinner, and I won't be able to use my app because my battery is dead. That would not be great. Third, because I'm using an API, I'm going to have an API key, some credentials that allows me to actually make calls out to this cloud API. And if I were building a game, I might have game logic that I want to keep secret. These we don't want in our actual devices because then a devious user could reverse engineer and figure out what secrets we're using, make calls out to the cloud APIs on our behalf using our resources. That's not cool. This sounds like a great fit for middle-tier architecture, but again, I really don't have time to spin up another machine. Luckily, we can make use of Cloud Functions. Cloud Functions is now out in beta and allows us to run a little bit of trusted code so that we can focus exactly on the code and not have to worry about spinning up or down servers based on our traffic needs. So let's go back to our architecture update. Let's go back to our architecture and update it. We have our app, which talks directly to Firebase using the Firebase SDKs. Now we're going to need to shift it so that we can add in our new features. We'll use Cloud Functions to talk directly to Firebase, and here I add it on the right-hand side next to my app because it acts as a trusted client. It also listens to the database and triggers a function every single time a database write happens. Because it's trusted, we'll be able to give it the API keys so that we can call out to our cloud APIs. All right, so this allows us to write our functionality once in a cloud function, allows us to move the heavy computation into the cloud and off of our phones, and we can store our API keys securely in our cloud function. So let's go back to our demo and see how we can write a cloud function. All right, so here I have my function set up. At the top, I have all of my imports, and I've already put in my service account credentials, which allows me to call into the APIs. This here is a helper function, and now I'll just have to write my actual functions to call into, to actually transcribe and translate the text. Step one would be to create our function. This allows us to say, whenever a new upload has happened in the database, we're going to call this function. We'll want to pull out the metadata. In particular, we're interested in the language it was spoken in, as well as the encoding. And then we'll want to call into our speech API, passing it our cloud storage reference, as well as the other metadata information, to transcribe our text. And once we have the result of that transcription, we'll be able to write it back into the database. Now we are writing it back under the transcripts node. This allows us to separate out our uploads and our transcripts. We put in the text as well as the original language, which allows us to translate it. So if I go ahead and record something now, hello world, I'll say something more interesting later on. We can go to our cloud console, and we see that the upload happens, and a couple seconds later, we see that we get a new transcript. And this time, it says hello world without me having to do any manual action. All right, now that we have this text, we just need to translate it. So let's jump back to our code. This time, we'll be interested in listening from the transcripts location in our database and writing it to the translations location in the database, similar to how we took our uploads location and wrote it to the transcripts. So we'll write one more function. Again, here we're listening for new transcripts, and whenever we get a new transcript, we'll want to pull out the metadata of what was said as well as the language it was spoken in. Then for every language that we support, we'll want to make a call out to the translations API, translating it from the spoken language to the languages we support, and then writing it back into the database under a new translations node. This allows us to separate out what the translations are so that our apps only download the translations. So if I go ahead and run this now, hello world, we see that it uploaded. I'm going to go jump to the console where you can see the transcripts and the translations showed up. And here we have the Korean for it. All right. So going back to our slides, we have most of our app now. Can we switch back to the slides? There's one step that I kind of glossed over, and that's how I get the functions from my computer to the cloud. This is a one-line command, Firebase Deploy, which allows me to take what I've written on my computer and deploy it to Firebase. But that can take a couple of minutes, so instead, I invite you all to go to babelfire.cloud on your phones, and we'll try this out in real time right now. All right, people have managed to get to the website? Okay, so I'm going to speak into my phone here, and I lied a little bit. I know a little bit more than just English, so I'm going to speak in Chinese. 应用成功了. Take a minute to upload and translate.
The application was successful.
All right, so my computer seems to have gotten it. Have you gotten it on your phones as well? All right, cool. So we have built a translation app using Firebase. Today I've used 3 of the developed primitives: cloud storage, a highly scalable object storage solution; authentication, a serverless authentication system to help us manage our users; and the real-time database to help us synchronize our data in milliseconds. Then I added to our Firebase app cloud APIs for cloud functions to enable us to actually perform the translations and call into our APIs for speech and translate. All told, we built a serverless app on stage in half an hour. If you need help building your apps, we have great, excellent developer documentation, as well as integrations into Android Studio and other developer tools. And we have free technical support. Thank you. My name is Kat, and I will be in the Ask the Speaker zone directly after this.